bond polarity. So this will help you to, this is where we determine whether the compound is polar or non-polar. Okay, and we do that by finding what is called the electronegativity difference. So you have to find the electronegativity difference in order for you to determine the bond polarity. So we don't just use this one to determine which one is polar. We also use this one to determine which one is the most polar and which one is less polar. Yes. So this is whereby you have like two elements in a compound. Let's say this. So each element is going to have an electronegativity value. So in order for you to find the bond polarity, you have to know the electronegativity value of the given element. Sometimes on the exam they will give you, but sometimes they won't give you. But you just need to know like those ones which they like asking, like hydrogen, oxygen, at least these ones which I'll write down: hydrogen, nitrogen, oxygen, carbon, chlorine. These ones I think you need to know them by heart. Maybe they might ask about them. Yeah. And without giving you the values, because the periodic table that they give on the exam, they don't usually give you the electronegativity values for these ones. I think even fluorine, yeah, these ones. But often maybe they might give you in the question. Then they just tell you to determine which one is the most polar. Okay. So bond polarity, we are going to look at two things: how you can tell which one is polar and which one is non-polar, and which one is more polar than the other. Sometimes you might have maybe a number of compounds which are polar, like they are all polar, but there is always one which is less polar. Okay, so we use what we call electronegativity difference. This is where you subtract. You're going to subtract this one from this one, and if you get a negative, make sure that you wrap them in a modulus, because it should be a positive. The electronegativity difference, like it has to be positive. Even if it gives you the negative value, wrap it in the moduluses. Let's say, for instance, I want to find the electronegativity for a compound having A and B. Let's say A is having 2, B is having 3. If I get -1, I wrap them in the moduluses, then I'll say +1. Have you seen? So in short, we focus more on the magnitude, not on the sign. Makes sense, right? Yeah. So let me just show you maybe a periodic table. This is a periodic table for electronegativity values. If you want, you can go on Google and search for electronegativity periodic table value, periodic table, just electronegativity periodic table. You're going to find a periodic table there, then you can go through it. Okay, yeah. So now let's first look at how we can determine whether something is polar or non-polar. Yeah. So first of all, before I even go any further, you need to make sure that, okay, so first of all, you need to check like which one is, let's say you're given to determine which one is polar and non-polar. So make sure that the elements that you're having, they are not ionic again, because they might try to deliberately maybe put the one that is having Mg and oxygen. Okay, this one you can't apply these concepts, because these ones are ionic. Okay, yeah. So we focus more on the covalent ones actually. So here's an example. Let's say you've been given H2, okay, and you have also been given, let's say, nitrogen oxide, monoxide, whatever. Yeah, then I ask you, between these two, which one is polar and which one is non-polar? Use the electron. And actually, I've showed you one way, right? There is a way of drawing the, whereby I taught you that one under chemical bonding, right? For those who have subscribed to my lessons, there is a way which you can do this without having to know the numbers. The strategy that I've taught. Yes, you just have to draw. You have to find the resultant dipole moment. Yeah, when I explain the dipole moment, go and watch my videos on dipole moment. I've showed how to determine this. You can determine this one without having to use the electronegativity numbers. Okay, but I'm just showing you this for the purpose of this lesson, in case maybe such question came. So there is a way to do this without having to memorize any numbers. I've taught that on the dipole. The dipole resultant. Dipole moment. For those who have subscribed to our learning platforms, make sure that you watch that video. This is like another method, okay? It's another method, but they all give same correct answers. So what you do is this. Draw the bonds, draw the structure. So here, this one can be drawn like this, right? This one you can draw it like this, right? And then what you do is that find the difference between their electronegativity values. So go, if they have given you the question, or if you have memorized them, if you are able to remember them, so write the electronegativity value for hydrogen, subtract the electronegativity value for the other atom, that is A, from the electronegativity value for the atom that is A. So I'm going to say hydrogen. What's the electronegativity value for hydrogen? The electronegativity value for hydrogen is 2.2. Have you seen? Now, minus the electronegativity value for this one. What am I getting? I'm getting 0. So the moment you get 0, it is non-polar. Now, for those of you who I was teaching the other way, the easiest way, the strategy. That's the strategy, in case you don't know. Those who have learned my other method, just know that I've taught you a strategy which most of the students don't know. Okay? Yeah. So this is another way in which you can determine if one is polar or non-polar. Now, if at all, first of all, you have to confirm that you are dealing with the covalent compounds, not the ionic compounds. Okay? Yeah. So now let's come to this one. Nitrogen. What's the electronegativity value for nitrogen? It is 3.06. I don't know if I'm mistaken, but yeah, I just write this. So 3.04. And actually the electronegativity values, I don't know, they differ, but the difference is not, as in terms of the decimals, they will be different in most of the cases. You're going to find this periodic table has got this, the other one has got that. So, but the number that is here, the whole number, it is oftenly similar. I'm just saying, because maybe you're going to encounter different periodic tables. So now subtract this one, this minus this. So it's given us negative 0.4. So you put this in magnitudes so that you can end up with a positive. So this one is polar because it is not given as 0. This only applies if it is covalent. Okay. So this is polar, this is non-polar. So they might give you maybe a bunch. So this is how you can, another way in which you can do it. I'm sure you've seen somebody who has taught like this, right? Now let's see how you can tell which one is more polar than the other. I have these questions from the tutorial sheet. They're saying that arrange the following bonds from the most to least polar. These. Have you seen? So, what you get after you find the electronegativity difference, it does not just represent the electronegativity difference. It also represents what? How polar that compound is. Okay. So meaning that if something is having a very large electronegativity difference, it is having a very large polarity. That's what we call polarity. So you are also calculating the polarity. So what you do is this. In this case, you are going to find the polarity for this one, polarity for this one, polarity for this one, and the one having the largest or the highest polarity, it is considered to be the most polar, and the one having the lowest is considered to be having the least polar, or to be the least polar, or to have the lowest polarity. Makes sense, right? So let's start. So here I have NF. Let's say solutions. So we have NF. So NF, what I'm going to do is that I'll write the electronegativity for this one, nitrogen. So it will depend if they won't give you, I don't know. Me, I'm not the one who prepare your tests, okay? It will depend with the person who will prepare. If it will be a frustrated lecturer, a sadist, who won't give you. They will put you in a situation whereby you'll be forced to memorize. I think a question came. Yeah, this kind of a question came actually. Yes, it came. And I'm glad it never came in our intake, because it would have been something else. A comeback wouldn't have been achieved. So 3.04. Okay, so it is going to give us, it's going to be a negative 0.86. I don't know if you have miscalculated, but just focus on the method. So when you wrap in the moduluses, these are the moduluses, it's going to give you 0.86. Let's go to the other one. Let's go to this other one here, OF. So what's the one for oxygen? It is 3.44, right? Minus fluorine, it is what? 3.98. And when you subtract, you're going to get something like 0.54, right? Which will be negative actually. We wrap in the moduluses because we are only focused on the magnitude, not on the sign. So I'm going to eventually get 0.54. And we have CF, right? Carbon, fluorine. So what's for carbon? The one for carbon is 2.55 minus. The one for fluorine is 3.98, right? Yeah. So when you subtract, you're going to get negative. Wrap it in moduluses so that you can end up with a positive 1.43. Whenever you wrap something negative in the moduluses, it means that it will automatically, by force, become positive. Just know that, okay? There is a video that I explained that. For you guys who have been watching my videos since day one, I explained the logic behind this in math. I think that is in math, yeah. So you're going to end up with a positive 1.43. So what I've just calculated, these are the polarities. So what I'm going to do is that I'm going to start like, they want me to arrange starting from the what? From the most to the least. So I'll be dropping, right? So we are going to start from the largest to the lowest, isn't it? From the most to the least, yes. So which one is the largest here? It is this one. So I'll just say CF followed by this one here, right? Which is NF, right? What have I just written? NF. For you guys who listen to NF, then followed by this one. It is the least one. It is having the lowest number here, so it is OF. Starting from the least. Yeah, we've started with the, with the most. We've started with the most. If I want, I can do this. We start with the most, right? If you want, you can write like this. This is greater than this one, which is also greater than this one here. Another way in which you can represent your answers. Actually, I recommend you after you write this, you also conclude with this. Your lecturer at least can see that you are a Joe B. Yeah. So this is how you apply this concept. This is how you calculate the bond polarity, like this, the way. Yes. hope that you have understood. I mean, how you can determine the bond polarity. One that is most polar. So this is where we determine which one is the least and which one is the most polar, basically. What else? I hope that you have enjoyed, and make sure that you subscribe to our YouTube channel. And if you haven't subscribed to our platform where you're going to access recorded videos where I've simplified a lot of complex concepts, make sure that you subscribe. And most importantly, subscribe to the YouTube channel. And if you've liked this video, click on the like button, share your opinions, what you're thinking. And if you have made any mistakes, just know that it is not intentional, okay? But I hope I've explained the procedures, you've understood the procedures in case and these questions came actually, they once brought this one. That's why I'm recording this. It's like for the past 10 to 7 years, so they have brought it about only once. So I don't know if they might want to bring it again on you who's watching this one in your intake. Because I know this video is going to stay forever here. Maybe even in the next 5 years, they'll be watching this video here. So maybe they want, if they feel like bringing a question in the next 5 years, or maybe today, I mean, this year, for you guys who are in this year, in whichever year are watching this video, yeah, so that you can at least have an idea. So, okay guys, so this is our platform where you access our materials. So you access our video lessons. So just click on videos, then depending with the term, if it is term 2, you choose, then you choose the course. So we have math, all these topics, the videos are here. In chemistry, all these has been taught. So there are full lessons for thermochemistry, all these lessons. And there is even atomic structure, periodicity, chemical bonding, organic chemistry. All the video lessons are here. All these are the video lessons. Even documents. We have solved materials. All the materials are here. Okay. So all you have to do is subscribe and you access all our materials. Okay. So make sure that you subscribe so that you can access our videos and our documents on our platforms.